Okay, cool. So real quick, if anybody has a laptop out right now, you guys should copy that fingerprint down and sign it because we need signatures on the release key for SecureDrop. So hooray, bonus points if you can sign that by the end of the talk. So yeah, I'm one of the maintainers of SecureDrop, and this talk is going to be discussing how we improve SecureDrop's security architecture, and the focus is going to be on explaining it in a way that would allow you to apply some of these other things to other projects and not just, laser focusing on the particular issues we face that maybe nobody else faces. So the very high level, actually hands up if you know what SecureDrop is. Okay, a few people. Okay, so for those who don't, the high level is SecureDrop is an open source whistleblower submission system that media organizations can use to securely accept documents from and communicate with anonymous sources. And this is something that we would stick in the newsroom of news organizations to allow them to keep their sources anonymous, because do things like just not say the name of our source. We could say we don't know and just deny it until we get left alone. But we have the problem now of global mass surveillance, where they like to say nothing is beyond our reach, and to some extent that is true. They can watch the networks, they can watch phone communications and whatnot. So in order to restore the capability of news organizations, journalists, to be able to keep their sources anonymous, we need technological solutions until we can, get all those government organizations back in check. Right now it's deployed with a bunch of major news organizations. This is a handful, there's a whole bunch more, but that's not what this talk is about. So our threat model is explicitly groups like NSA, GHQ, and the rest of the Five Eyes. We assume that the kind of people who would want to be submitting things to SecureDrop are the kind of people who would be actively targeted by intelligence agencies or local governments and whatnot. So we have a very paranoid threat model we work with. The two main things we're trying to protect, specifically, number one is source anonymity. That's the number one thing that we would like to retain secret at the end of the day. And the second one, which is very closely related, is document confidentiality. So if somebody gets the documents, the source leaks, they could use those to de-anonymize them, even if the source is communicating over Tor. So these two things are really what we focus on during development. And the question again, who do we want to protect it from? Well, in reality, it's actually everyone, but really nation-state corporations and local law enforcement. And we know that these kind of groups are actively targeting journalists. You can see press freedom violations around the world. There's actually a press freedom tracker that does track some of these things. So we do know that this is happening all over, all the time. And if we know those are the people who are the threat actors when we're developing this, we say, okay, well, what can these people do? Actually, kind of can do a lot of stuff, but really intercepting network traffic is a huge one. If somebody can watch network traffic, they can see, 800 megabytes of files move, and then there's an 800 megabyte file sitting on the server. We can kind of correlate that and say that was a lot of Tor traffic. We have a good idea who that probably was. They can maybe hack into the servers, maybe not, but it's a good chance that in a very long run, somebody may hack into one of the servers. And we also see things where they will send agents to physically seize hardware. And in this context, what we do not protect against is where somebody breaks into the office, sticks in a bad USB and malwares. We're talking about an agent as part of like a subpoena, picking up the server and just taking the server and running off with it. And this could include doing cold boot attacks where they, drop the memory into something cold and then reboot it later and read the memory out. So we do care about servers' memory being pretty clean. And the last one that we work on a lot is people submitting malware to users of SecureDrop through SecureDrop itself, because of course they're going to open the document on one of the workstations and it's kind of guaranteed. Phishing emails, maybe not going to open it. It might look suspicious, but somebody says, hey, I have this, great PDF about, some illegal operation, you're going to open it. Okay, so another thing with this complicated threat model is it is infinitely complex. Like, we could just go down any one rabbit hole until our eyes bleed. We could talk about any one little thing forever, and we're going to try to focus today on just a few of the bigger changes we made lately and some of the bigger screw-ups. So the current state of things is we have one application server that runs all of our code that is mostly what SecureDrop is. And that is a GR security patch kernel to help minimize the types of attacks you can do using memory corruption. We run a Python application. We store our data in a very small SQLite database, and we run all this behind Apache. And on top of the application server, we have a firewall that blocks all inbound traffic. So this server is only accessible through its outbound connections through Tor hidden services, including for administration and for sources and journalists using it. This again is monitored by a monitor server using OSSec to try and look for intrusions. And lastly, this is connected sources and journalists both connected all this through Tor in roughly the same way. And then a journalist will retrieve documents from the journalist interface and take them off to an air-gapped laptop to decrypt them. So that's basically how it works. Our development is actually very simple. We write a feature, we write tests, we write unit tests, we do functional tests with Selenium, we write multi-stage tests to test deployment and provisioning with Molecule. We write a bunch of documentation to help sources and admins and journalists and developers. We do mandatory code reviews for everything that gets merged by at least 2 members of the team, so the person submitting it and the person signing off on it. We automate testing, we do linting. This is all pretty normal stuff for development. So this isn't actually that special of a thing that SecureDrop does. But what's interesting is that like at every step, we actually put like a lot of effort into all these things that we know that we can run end-to-end a complete submission set through the browser at every single pull request, every single check-in, and we do have to have some automated testing or manual testing because we're using a bunch of different USBs plugged into a bunch of physical hardware. But in the end, this isn't that interesting of a development process. But what we're trying to do is keep each of those things like as high functioning of a level as possible during the whole development. That said, it's kind of like fighting little fires all the time. So, we as software developers, there's an update to something on the operating system, and now you have to patch it because, okay, cool, this library is no longer compatible with this library, or the operating system becomes EOL'd, and every couple of years you have to change your operating system. So that slide before about our development process, like keeping that so that it's very easy to go through the entire process each time really helps us with actually developing secure features, because we're not getting bogged down saying, okay, we had to update one Python library and we spent 9 hours debugging what broke. No, we try to really say like that library change should be quick. We just push off the CI, and half an hour later we get a green light or a red light if that feature worked or not. So, I forgot what I was going with this slide. There's something about like things break, but I don't remember where I was going. Pretend the poop emoji is not there, but things do break. And so since this talk is about improving the architecture, we're going to actually focus on the things that haven't gone well in hopes that this might help you guys in future projects not make some of the design decisions or mistakes that we've made in the past. So one of them was, this is a tweet from Kevin Poulsen, and over the summer or early fall, he got a submission to SecureDrop that when he untarred it, it turned into a desktop file. Nautilus executed the desktop file. The desktop file ran arbitrary Python, scraped the GPG keys, and then posted a signed message back to some server somewhere. And he posted this to Twitter, which is how we all found out about it. And we had to then go through and figure out what happened. And so really the root cause was that Nautilus allows an executable file with allows a file with the executable bit set to run any arbitrary code. And this allowed the attacker to run Python that scrapes the keys, put them in a document with a QR code, and that QR code, when somebody scanned it, pinged the server with the data from the air gap. And so this is a very complicated attack, but this does happen. And so what really went wrong, though, is that the secure viewing station isn't a true air gap. We're allowing people to move USBs off of it and move data off of it. So we do know that at some point data will be leaving it, but we didn't tell journalists, by the way, be very careful about what you're taking off of it, because that actually might be a trick. That's roughly equally as hard of a problem as telling people not to get phished. Like, if anybody here is a security person, okay, well, your users are going to get phished all the time if you work for a big company, and there's basically nothing you can do to realistically train every user to not be phished. Like, it's inevitable. And so in that case, like training users not to scan certain QR codes, like it's just a losing battle. And so this kind of, the issue we have with this is imperfect isolation. So we allowed arbitrary code to execute in the same environment that contained all of our GPG keys. And so like the future development of this would be finding a way to sandbox the decryption code and the like viewing of document code from where the actual like keys are stored. And like this is something we've kind of known that that workstation doesn't have amazing isolation. It's pretty good, and it's hard to get information off it, but stuff does happen. So like if this is the current workflow where you have like the source connects via Tor to SecureDrop, the journalist connects to Tor again, or connects to SecureDrop via Tor, and then moves these USB sticks around. It's a lot of manual work, and it's a little bit frustrating to work with if you're constantly having to like move encrypted USBs back and forth between devices. So our future design decision that we think will decrease like the manual processes that journalists and admins could make mistakes on, and also increase the isolation of our system, is moving to cubes to have the decryption and the document viewing and the keys all stored in separate systems, so that we're not running the risk of random malware files executing in the same VM as the actual decryption keys. So this was brought up earlier in another presentation, but loosely, like this would be sort of the workflow, so that when the journalist connects, they would connect through Whonix to have like their nice Tor circuit to get out to the SecureDrop application server, pull all this stuff down, and then each document would be opened in a disposable VM. We could then clean the documents and say, okay, this PDF has really just been rendered to a whole bunch of screenshots, which means we can go forward and hand these PDFs out to the entire rest of the company and know that we didn't just either like malware the whole company or pull information off of the air gap. So we were trying to keep things clean so that when documents do leave the SecureDrop area of a news organization, we're not giving infected files to the entire trusted internal network of the company. So another thing that went a little bit wrong is Tor made an update, and this thing that went wrong was not Tor's fault, it was our fault. We were running a custom AppArmor set of rules against Tor, the Tor binaries and Tor file system, like files. And when they shipped this, it broke the AppArmor rules, and it knocked every single SecureDrop off of the network simultaneously, because they all updated to new Tor and we got kicked off. So update AppArmor rules and push those out to everybody to fix this. And so that's one of the things, is that we have a lot of dependencies, and every system has a lot of dependencies, and the more you can control your dependencies, the less likely something will move under your feet and break part of your system. And what we've done to fix this actually is we no longer use upstream Tor directly. We actually mirror the entire Tor repository to a local Freedom of the Press Foundation controlled secure app repository, and then we point our SecureDrop servers to this new Tor mirror. And actually, Connor in the back over there is the one who, I believe, did all this. Am I right? Yeah? Yeah. So Connor implemented this, and this pull request, again, like lets us now have a little bit more control over our system, so that external factors, like or external dependencies changing, still have to go through QA, so that we know that we can go end to end on the system. We can provision systems. We know that the entire process still works before we push this out to some 60 news organizations around the world. The next major usability thing like for security that we did is like a UX improvement, which was we translated SecureDrop into a whole bunch of different languages. And there's right now, this is just a handful. There's a lot more done, and this is up on the web, and we're actively working on translating more and more of SecureDrop. And this is actually, it might not sound like a secure architecture thing, but from the sense that like the system as a whole does rely a lot on administrators and journalists and sources doing correct behavior at every step along the way. Like this helps sources, if we tell them memorize your password, don't share your password, like only connect with Tor browser, if they're doing that in a language they don't really know, which was only English for the longest time, it increases the chances that they're going to make a mistake. And in a sense, because we are the stewards of this project, it's on us to ensure that their behavior is nudged along in the correct direction by a good user experience. So people like to talk about the coolest encryption algorithms they use. For us, if we say if we tell them, do X and they can't do that one X thing, they immediately de-anonymize themselves. That's not any good if we use the sweetest, latest crypto. So making these good UX changes also does impact the design and return of the program. There's little small things. Every time we have a string, we have to rethink about how we actually assemble these strings, because you can't just drop random nouns at the end of a sentence, because in some other languages, you have inflection and declination and whatnot. And so this is only a small example, but going through the code, there were a whole bunch of places where we did things like pluralize things by string concatenation by adding just plus s to the end, and that doesn't really work when you're internationalizing. So on top of that, there was a whole bunch of changes we had to make to the development process, and one of them was developing a workflow that allows us to submit all these strings out to somewhere where we can then solicit translations from the community, building these back in the application, and then also knowing that any feature that requires a string change would have to go through a longer process or have a longer timetable, because we do require outside contributors to do these, especially as the number of languages grow. So, making a quick patch into a release to quickly get something out sometimes can't happen anymore. So we try to think about how we're going to develop in a way that gets these fixes in and allows people to ship things out without, constantly saying, oh, we broke a string, and then, bothering the community. Another thing on the UX side is this is the old landing page, and it's a little hard to read at the top in this font, but it says, we recommend using Tor browser to access SecureDrop, learn how to install it, or ignore this warning to continue. And this warning is flashed via CSS via the user agent in the HTML when somebody hits the page for the first time. And so we did some user testing, and I say we as in the engineers, which is to say we are probably not qualified to be doing user testing. And they said, oh, that sounds scary, I did something wrong. I'm just visiting this for the first time. So after a little bit of talking to some people, we switched this to being purple. Say, okay, purple is a less scary color. Now when users see this, they won't think they did something wrong. And then the downside was immediately I would ignore this, because it's just part of the design. It looks like a purple banner, and nobody listened to this anymore, which again says we're engineers. Maybe we shouldn't be doing this sort of thing. We should go out and we should find people who are experts in the field of user experience and user interfaces, and have them really do an audit of the app. Say, okay, us as engineers, we think we had this nice secure pattern, but do we? What are the hidden things that are going wrong? Maybe this text looks pretty normal to us, but to the average user, it's turns them away. It encourages them to do bad behavior. So again, secure architecture might mean a lot of things, but it also does include the user experience side of this. Another related architecture thing was we had at least one dedicated admin who would then get emails every time there was an OSSec alert, and they were getting fatigued by this. And we don't know exactly how they were, but we know that there was a complaint that there's too many emails. And if somebody's getting an email every 30 minutes that says oh, app updated something, oh, this happened, oh, that happened, and none of it is actionable from a security perspective, we're going to wear them down so that the day that there actually is an intrusion, they just delete it with their other things, or they set up a filter so that there's one inbox with 10,000 unread OSSec messages, they're going to miss it. And so we had to go through and really work on our rules for OSSec to say, okay, cool, this is not necessary to alert, we should try to avoid this, and we're trying to shrink this down as a team so that the people out in the field who are doing the day-to-day operations of SecureDrop aren't being overburdened and then, being incapacitated in their ability to be effective admins. So those are some things we've worked on in just the past, 8 months or so. and still working on some of these things right now. But one of the big changes of the future is moving away from SQLite to Postgres. So this kind of falls under the principle of least privilege. We have applications that are, when they interact with SQLite, they can just do anything to it. That means the source interface can read journalist passwords and usernames, which is, there's no reason it needs to do that. And that's a limitation of SQLite right now. So we're going to move to a bigger database that has better access controls. And it would also be interesting in the future, because if we do want to do something like make SecureDrop highly available, we say we have 3 application servers that all sit behind onion balance. They would need to share a database, and you don't want to do that on a file system. So you would then want Postgres available via TCP sitting behind the firewall, and then you can have many application servers interacting with one database server. Oh, that slide is not done. Anyways, so 2 of the major things we've done recently were, we also had to get to the point where we could even add Postgres. We then first had to add Alembic, which is the Python library and command line tool for applying database migrations. And before we could do that, we also depended on Flask SQL Alchemy, which was not implemented in the original Flask application. We also have to do a pretty large refactor of our tests. And before we could even do either of those 2 things, we had to also do a large refactor of the source and journalist applications. And so, like, even to make this one change of preventing the source application from being able to read the data for maybe like the password hashes and usernames of journalists, like, it's like many steps to get away from this. And so it's not actually terribly interesting of a task. Like, this is what I do day to day, and it's actually quite boring. But like, that's a really important thing with secure software, is there's just like tons and tons and tons of tedious work you need to do like every step along the way to have like a well-formatted application that's is modular, that allows you to make updates, allows you to quickly add tests and verify that the behavior is correct. So like, this isn't a fun presentation slide. It's just, there's crappy work you have to do to make secure software sometimes, and that's kind of part of being an engineer. Like, talking to Connor last night about this, and his analogy was that, a big old skyscraper is really cool. Pouring concrete, and pouring concrete is a pretty boring task. So like, us as software developers need to do more concrete pouring. Another, hopefully, improvement is right now we have started to Dockerize the development environment to make it a little bit easier for everybody to set things up, which isn't strictly a security fix at the moment, but we're potentially moving from the current app server design, which is just everything piled onto the application server and running all in the same user space, into this is also up for debate. So anybody on the team who doesn't like this idea, you can yell at me later. But this is something we're considering doing, which is splitting off the different parts of the applications into their own containers, and then restricting who can talk to what. And so the source application doesn't actually need to talk to the internet ever. It just needs to listen on or make itself available to Nginx, or the source application also doesn't have any reason to need to talk to even be able to like hit the IP addresses of the Postgres database. And so by kind of removing things, we get the benefit of like separation of responsibilities, but also we know that in the containers, we can be a little bit more creative with the dependencies that we need across the different ones, and not worry about system dependency collisions or things pinning versions and holding us back from updates we need because of, locked dependencies. And it's not a huge issue, but it is a consideration that we can then control a little bit more how each of the different pieces fit together. And on top of those few advancements that we're looking at, which are not massive but somewhat big, one thing that came up this summer or fall was there was a research paper about fingerprinting onion services, which was looking at if you sit between the user and the guard node, or you are a bad guard node, and you watch Tor traffic go in, and you say, okay, cool, I can see an encrypted stream coming in. Can I guess what onion service that is? And can I guess what they were doing? And it turns out that yes, you can in a lot of cases because there's not that many onion services out there in the world, and there's not that many that get a lot of traffic. So if you're trying to make a guess who's using, time's up, what? Okay, anyways, this is something that is an interesting research question, but we don't have enough bandwidth to be able to effectively deploy mitigations against this, because we'd have to write mitigations, then test them and verify that you can't fingerprint SecureDrop as an onion service after these have been applied. So if anybody is a machine learning expert and wants to help us, or if any of these people in the audience, come talk to us afterwards and we'll have a chat. I guess maybe time for 1 or 2 questions. Cool. Yeah, take a picture of this if you want to come join us, and yeah.
Mentioned the importance of internationalization, lots of different parts of the world we work in. Do you find that the nature of the threat varies depending on the different types of news organization or different countries in which they operate?
Yeah, so when FPF for a long time was kind of, oh yeah, so the question was, do we see different threats across different languages and across different regions? And for a long time, one of the things on SecureDrop was that it was assumed that people would know, like the NSA would know that some news organization has SecureDrop running in their office at this location, and we were relying on the US legal system to protect the servers. But running, say, SecureDrop in a country with a hostile government might be different. So like in that sense, like using Tor becomes more risky. Like then you want maybe your onion services to actually be more anonymous, and the threat model does change as you move from around different news organizations around the world. Okay, do we have, what time is it? Do we have time for more questions? All right, maybe one more question?
No.
Anybody else?
Can you show again the GPG key?
Yeah, so, oh yeah, that's actually a good one. So this is the GPG key at the beginning. If anybody could take a picture, oh my God, so many animations. Cool, this one. If you guys could sign that one, that would help us ensure the integrity of this. Admins use that when they install SecureDrop. So if you want to help admins correctly verify that they have the real authentic SecureDrop software, signing this would help us. Cool. One more question?
Yeah, I just wanted to ask, how many languages have you got your documentation in at the moment?
The documentation is only in English because it's pretty extensive, and we don't have a plan at the moment to implement that. We have only implemented the documentation on the source and journalist interfaces.
The translation?
Yes. Yeah. So I mean, you can talk to us after that. That one's a complicated question because we don't know. This internationalization thing, which is actually the work of Loic over here, who's did pretty much all of.
The short answer is we have 7 languages currently and 4 in the works. And if you know a new language, it's easy to configure.
Yeah, but she asked about the documentation.
It's
Yeah.
not the documentation, it's the application, translation, 7 languages.
Okay.
Yeah. Cool. Do we have more time? Maybe, who is the next presenter here? Next presenter is not here. Maybe more questions. Cool. In the gray?
Okay, pardon my English. I just wanted to know if you have planned to integrate like provider to avoid stenographic attack. Like when a source is publishing a PDF document, maybe there are hidden fingerprint in it, and
Yeah, so I think, I know there's some things like Tails comes with the metadata anonymization tool, which will strip out some metadata. But if you do something like, you have like printer dots, or there's like some way that images were subtly manipulated when they download them from a server, like a very small watermark on them, like we don't know about that. So that would fall more under the training of journalists about how to redact information or release documents selectively and how to, assess that themselves. That falls a little bit outside the scope of the SecureDrop software, but it is relevant, and I don't have the best answer for that one. Is the next presenter here for the next talk?
We'll switch anyway. Maybe it's outside.
Okay, yeah, I guess let's rotate. Cool, thanks everyone.